sac127 number 2. How long must a simple pendulum be in order for it to have a period of 1.00 seconds? Okay, we know the pendulum is related to its length. The longer it is, the greater the period. We do have a formula on the formula sheet that gives that relationship between the period and the length of the pendulum. Here it is right here. Always note it's got no mass in it, but it does depend on the gravitational force constant. So unless we're given information to contradict the assumption that we're dealing with an object or a pendulum near the surface of the planet Earth, we make that assumption. So copying that formula sheet over here, I get T is 2 pi times the square root of L over G. Now we're supposed to find a pendulum that has a period T which is equal to 1 second, and what we want is the length. So we just have to solve this equation for the length. I'll divide both sides by 2 pi. I got to get rid of the square root. The inverse function to the square root is the square. So I'll square both sides. And I'm going to switch sides here. L over G is, and I'm going to distribute that square among we got a product in the denominator and a fraction here. It's T squared over 4 pi squared, and then multiply both sides by G. So I got L is equal to T squared G over 4 pi squared. L is equal to, that was 1.00 seconds for the period T, 9.80 meters per second squared for the gravitational force constant, or acceleration due to gravity, and all divided by 4 pi squared. So the units are going to work out to be meters per second if I don't remember to square this, and now the units work out to be meters, which is what we expect for a length. Plug those numbers into the calculator. Out pops 0.2482, and it is in meters. So to 3 sig figs, which is what the time was given to, the length will just be 0.248 meters.